All right, so this is a rehash of a talk I gave previously that Eric saw and invited me to come and give it again. I think you guys might be interested. I would like to just make a slight correction to my introduction. I just joined Sphero in the last year, so if you have Spheros from before that, I had nothing to do with it. But hopefully you'll see some of my stuff coming out in products in the future. What I'm talking about actually isn't what I'm doing at Sphero. This is just more stuff I'm interested in. So I do machine learning and artificial intelligence, and a big thing lots of people do these days is user experience and user interfaces, UX, UI. And I've been thinking a lot about how the two things interact as AI and machine learning come more mainstream. And so that's what I'm going to talk about. And of course, the first thing I'm going to want to do is define my terms. So lots of abbreviations, AI, ML, UX, UI. What are all of these things? And the takeaway from today's lecture or talk is they're probably not what you think they are. They're certainly not what I think they are, but this is my best chance, best shot. So artificial intelligence. I look it up on Wikipedia, and I find that it is the effort to so precisely define human intelligence so that a machine can simulate it. So you want a machine that basically fakes being a human. Other definitions involve, agents that perceive the world, take actions to maximize success, and of course, this is a moving target. And so over the years, as people have made better and smarter and more intelligent machines, everyone keeps saying, oh no, that's not really intelligence. So for a while, chess was the hallmark of human intelligence, and then machines did great jobs at chess, and now they're like, that's just a trick. And now Go is the big thing. Anyone here play Go? So,
Pokemon Go? Is that what you're
saying? No, not Pokemon Go. Go the game.
That's like the #1 game in the world right now.
I don't know if anyone's tried to make an AI play Pokemon Go. Probably wouldn't be too hard, I think. But no, Go the game with the tiles. Apparently it's really hard. I don't play it myself. And everyone said, computers could never do that. Excuse me. And then, of course, Google came out with AlphaGo and is now winning Go. And they're like, no, it's not really intelligence. So it's really hard to do AI because every time you think you've done something, people tell you didn't actually do it. So main issues in AI are reasoning, knowledge, planning, learning, communication, perception, all these things. The goal of AI is, of course, general intelligence. So we want a machine that can do basically anything a human can do. And there's all sorts of fun philosophical questions as to what does that make humans useful for once we do that. We're not going to talk about that today. So I mentioned chess. Chess used to be the classic AI problem until we solved it. Nowadays, autonomous vehicles is a big thing in AI. So how do you have a car that drives in Colorado in the snow today? I wouldn't trust any of the autonomous systems out there right now, but eventually they're trying to do it. So machine learning is a tool used for artificial intelligence. So often these two things are sort of just stuck together, but they're distinct things. AI is a really big field. Machine learning is a subset of AI. So what's ML? Machine learning is the idea to give computers the ability to learn without having to be programmed explicitly. So you have a task, you have something you want the computer to do. You're all programmers. You all know how to sit down and write, if statements, switch statements, branches. You have all that control flow. And if you know how to do what you want to do, you can teach the robot, I work with robots, but you can teach the computer how to do it. But what if you don't want to write it down? Or what if you don't know how to write it down? So machine learning is how to derive these things from data. So you have to give it a whole bunch of data that says, this represents what I want to learn. Go learn it. And that's machine learning. It's great. It's also very dangerous because you don't necessarily know what's going to come out. And that's one of the big problems with machine learning is you train it, and you try to train it well. It's a lot like raising a kid. And then you send it out to the big wide world, and who knows what happens. So a big thing people use this for these days is spam filters. Who here receives spam email? Who here has a separate spam folder that somehow magically all your spam mail ends up in? Yeah, so that's machine learning on the back end. That is, you're training it, you're giving it examples. This is spam, this is not spam. And it's trying to figure out what things are. So these things I know a lot about. These things I don't. So I looked up user experience, and I got this great picture of a horse. And it tells me, the internet tells me that user experience is the entire experience about a product. which I found really interesting, is not just the use of the product, but also the anticipated use. So it's just how you feel about this thing. And it's all these emotions and beliefs, and it's everything all wrapped up, which is really cool. It reminds me of a kitten, because I like kittens. And like, there's a lot in the experience of a kitten. And just like thinking about petting a kitten is great. If you like cats. If you like dogs, substitute puppy, and you'll be fine. So that to me is user experience, which I thought was really cool. It's also about establishing emotional relationships around your product or around the thing that you are building this experience. And so I look at Apple does this really well. Who here owns an Apple product? Who here owns more than one Apple product? More than 2? More than 3? More than 4? 5? 6? 7? 7? 8? 5. Okay. I don't know if you're like still up there. No, 5. Okay. People who really, really love their Apple products, even though, in my opinion, they are subpar a lot of the times. You'll note that I'm using a Macintosh. I am actually running Windows on my Macintosh. I'm actually running Keynote in a virtual machine on Windows on my Macintosh, because that's how I have to get things to actually work properly.
I ran Windows on Apple too.
Yeah. So, but people are really obsessed with them, and that is a great experience. So then what is UI? I draw a little parallel here. It's kind of sketchy. UI is to UX what ML is to AI. UI is a smaller focus within UX, I think. This is what I learned from the internet. And this is where these interactions actually take place. It's not everything around the object. It's the actual interactions with it. It's all about making the interactions effective and enjoyable. And it can be on all sorts of different devices, even in the physical world. So here's what I thought was a really fun UI. If you can see this, this is the control panel for the space shuttle. This is a lot of dials and switches. And this took people to the moon, I think, maybe, or back, somewhere in space. How would you redesign that given today's technology? I think that's a really fun thought. So, a little bit more on AI. Classic artificial intelligence. So when you talk about AI, there's this subgroup called good old-fashioned AI, GoFi. And it basically involves logic, planning, and search. These are classic AI problems. And so how does it work? Imagine you have a bunch of states, and you are in a state, and there are some actions you can take. So you can drive up, down, left, right, north, south, west, east. And you have a place you want to go, which in this case I think is Atlanta. You want to go there, and it's all about how do you chain together the actions you can take to get from where you are to where you want to go. And voila, there you go. And this is your basic problem, and you can apply this to chess. This is how people did chess. There's states of the board. There's rules, the actions you can take in those states, and you just gotta try to get to checkmate. So just plan. And this is how people thought you could deal with everything in good old-fashioned AI. You could deal with, in fact, tic-tac-toe. So this is the complete tic-tac-toe game table. This tells you from every move all the options you can do and how to get to where you want to go. So they thought, and for chess, this is really hard, but if you could build this giant table, find the one that says I win, and then just follow the tree down to I win. Tic-tac-toe is really easy. I encourage you to memorize this, and then you can defeat small children every single time. Although you can't actually. It's really hard to force a win in tic-tac-toe, but you can do it. But they said, all right, if we just do enough of this, we can solve anything. And we can solve people. So this is a way to address life. Here's a person. That's what you want. That's your goal. And there's some rules, and if you just knew the rules, you can get from one to the other and help you make decisions like, should I take the burger flipping job or should I go to college? And the rules tell you how to make these decisions. Of course, humans are a little more difficult, and this is why building androids has turned out to be hard is, we're not really sure what the rule book is. Is it the Bible? Is it the penal code? And you're not even sure what the goal is. Is it money, or is it, save the planet, or what? But the idea was if we just knew these things, we could solve anything. And that's classic AI. Machine learning is, as I mentioned, a subfield, and it grew out of building those tables and setting all those rules was really hard, right? So could we instead learn those rules? So if we watched maybe enough people, could we derive the rules for life? Or more simply, if we just watch enough tic-tac-toe games, could you figure out the rules of tic-tac-toe? The answer is yes, but I'm not going to talk about that. So there's two main groups or classes of machine learning approaches. One is classification. So here is a woman classifying things. There's categories: plants, mammals, insects, birds. She's got a rabbit, and she's got to figure out which box this rabbit goes in. Who knows? Mammal, yeah, rabbits, good. Just making sure you're awake here. Rabbits go into mammals. So that is categorization. There's a discrete set of categories. Every object goes into a category. This is regression. We're trying to find a real valued answer to a query. Anyone play with HowOld.net? Came out a couple years ago. It was Microsoft. You sent a picture of yourself up and it tried to guess how old you were. So there's features they extract from your face. Eyes, color, how many lines you have on your face, if you're smiling or not. And then they try to regress to get an actual numerical answer. It's not, are you old or young, but you are 35, you are 43. Specific absolute numbers. So here's a little toy example. You can train these systems in a number of different ways. One is called supervised learning, where you give examples. So here I've given you an example of a categorization. This is how I like to categorize my fruit. So when I query you, where do I put this peach? You can probably tell me. In the box with the other peaches. Yeah, this is my training example is peaches have gone over here. And so when you see a new peach, you put it there. This is supervised learning. An alternate is unsupervised learning, where I just say, here's some fruit and vegetables. Categorize them, please. How would you categorize them?
Color.
You jumped ahead a slide because you've seen this talk before. One is you could go back to the way I just showed you. Sort it by carrots with carrots, oranges with oranges, beets with beets, etc. Sort it by type of thing. Another option is, color. So when you have unsupervised learning, you're never quite sure what you're going to get out. Because the system might say, like, well, this makes sense. These things are more similar. I'm going to put the carrots with the peaches, even though if you ask someone, do you want a peach, and then you give them a carrot, they'd be really disappointed. So that's supervised versus unsupervised. And they have pluses and minuses. But let's see how these things play out in the field. People familiar with Siri? Yeah. Siri is possibly the most popular application of artificial intelligence these days. Who's spent any amount of time talking to Siri? Okay. You have nice conversations?
No, there's some error with my phone where she just automatically starts talking sometimes.
Okay.
That'll tell you.
Maybe sentience has arisen. So Siri is an example of a dialogue system. So basically, it's an expert system where they have questions, and then there's just matched answers. This is like that table we saw for tic-tac-toe. This is a tree for conversations. You ask a question, you get a response, you choose the right answer based off this response, and you keep going. And then, of course, they try to make it a little bit more fun by throwing in fun things you can ask. And these are just humans have written down, this is a thing that you should have a response for, such as, where can I hide a body? Call me an ambulance. Did you fart? Because that's the thing people ask their phone. Are you going to kill me? I want to rob a bank. Which is better, pirates or ninjas? Things like that. People thought this would be fun for Siri to be able to answer, and so they just put it into this tree. So it's not machine learning, because it's not really mining this from the data, at least this part isn't. This is just AI. This is just, here's a decision tree, use it. You can see some machine learning also in use in this sort of AI. This is similar to an autocorrect system. So this is mining data, trying to predict what's going to come next. So when you've seen what is a toad and where is the road, you can start to learn what words follow other words. And so if I start, what is, What's going to come after that?
A.
A, yeah, A comes next because it's most likely from what is a toad. But it also could be the, because maybe I'm saying what is the road. So you start to learn these things as you see more and more data. This, of course, can lead to hilarious failures. Because again, you're only as good as the data that comes in. So autocorrect, if you've ever used it, you'll know that very often it's not so much autocorrect as auto guess at what you might be trying to say and be wrong some of the time. But these are really, really useful, and they're out in the field and they're used every day. So this is AI that's actually out there being experienced. Eliza is one of my favorite examples. This is a system from way back when. It basically did this. It was a conversation system with a little bit of learning of what follows what, set up in the style of a psychologist. So you would log into the system and it would ask you things like, what do you want to talk about? And you say, I'd like to talk about my problem, or I'd like to talk about my parents. And it would pick up on parents and be like, okay, tell me about your parents. And it would just ask these leading questions. Not really that intelligent. People got obsessed with Eliza. People told Eliza things they didn't tell their partners.
How long ago was this?
This is in the 70s. You can find some clones online now to play with because it's a fascinating study. And just for those of you watching, if it's not the 70s, I'm sorry. It just seems to be what I think it is. People got so attached to it and so engaged, even though it just was really not that clever. And so a little bit of AI, a little bit of ML used properly can come up with really engaging products. So a little bit more on ML in the field. Anyone use any of these products? Amazon Pandora or Netflix Max? I've actually never met anyone who's used Netflix Max.
I was saying, what is Netflix and Max?
Yeah, I don't know if they've actually continued doing it. It's supposed to suggest movies for you. These are recommender systems. So machine learning has gotten really popular as a recommender system. And where they try to say, if you read this, you'd like this. If you've bought this, you might like that. And there's a few different ways to do it. One of my favorites is actually the one that's behind Pandora. So say you have a song. This is We Are Never Ever Getting Back Together with Taylor Swift. And what they do is they extract features. So the Music Genome product has categorized these 300 different features of songs. Is it melodic? Is it harsh? Is it fast? Is it slow? Is it a woman singer? Is it a male singer? Is it a band? All these things. These are all features. They're not all binary. And so Taylor Swift maps to a certain feature set, and then they say, rate it. And so you rate this song. Pop quiz. Is this a categorization or a regression problem?
What's a
Categorization.
And you said, what is a regression problem? Regression is when you try to get a real valued number out the other side and not just a bucket. So it's not the bucket of mammals and insects, but the actual number of your age. So the answer is,
That was my guess.
could be either, actually. So you could say these are 5 buckets, 1, 2, 3, 4, 5 stars. But if you want to allow for like half stars and quarter stars, then it's a regression problem. So you can address the same problem either way, which is true about most of the problems. So anyway, here's your song, and you liked it, and then it comes off in the new song. This is Party Hard by Andrew WK, which has a different feature set. So they extract different features and then try to predict, given that I liked We Are Never Ever Getting Back Together, how will I feel about Party Hard? And the answer is I probably don't like it if I like the other one. Or maybe I do. And then when I respond and say, no, actually, I love that song, that's another data point that they then have to learn from. So recommender systems are everywhere. It's hard to even walk into a store without having them say, oh, we think you might like this thing as well. So this is really popular use of machine learning. When you don't have individual data, sometimes they fall back on categories. So they'll learn a whole system not just for you, but for all women and all men. And then when they don't know anything about you, they say, well, you're male, so you might like what men like, and therefore they'll recommend Taylor Swift. I don't know. And then they can even do it geographically. So a lot of things are doing automatic localization by saying what's popular in Colorado these days versus what's popular in Maine. And so you'll learn if you go hang up on Amazon, it's not just what did you buy, but what did people near you buy? Because if everyone here suddenly starts buying snowshoes, hey, maybe it's winter, and anyone else might like snowshoes as well. So these basic AI and machine learning techniques, which are not really cutting edge, this is stuff we've known about, just been refined over the years, have had some great successes. Anyone use Facebook? You know, when you take a picture, upload it, now it just boxes people and suggests who it might be. Kind of terrifying, but kind of awesome. Face recognition has been a fantastic success. And the way this works, again, extract features from a face and figure out who it matches. This is a categorization problem. Everyone is their own bucket. These are all pictures of Dan. These are all pictures of Eric. What is this picture of? Is it Eric or Dan? Done. And if you have enough pictures, it works really well. Basically, it's as good as fingerprinting. So that's technology for you. Anyone recognize this? Yes. So deep learning has become really popular of late, and Google has been throwing it at everything. We're not going to go into deep learning. I have strong feelings about deep learning, but it is right now making sort of a comeback. So this is deep learning trying to find in a picture where the dog faces are, basically, and then enhancing the dog faces that it finds to make them more like dog faces. So there is a dog. Everyone see the actual dog?
Yeah.
And then lots of things that could be dogs but aren't. And this is caught on, and there are now a bajillion different startups all trying to leverage deep learning to do something. If you're looking to do a startup and you're looking to do deep learning, I would suggest you see how many of these guys have succeeded and then reconsider. Because there have been lots of failures. This was a deep learning failure. This is Google's image classification system. Anyone spot the failure?
Gorillas.
Yeah. This caused them a bit of a problem. So, yeah, it tended to tag people with darker skin as gorillas, which people unsurprisingly found quite offensive. And so, because they were using a learning system that it was hard to interrogate and figure out why it was making these decisions, they ended up just deleting the gorillas class entirely so that nothing could be categorized as gorillas. Because that's how they fixed it. That's a big failure. Anyone play with Tay when she was out? This is a little more appropriate back when I gave this talk the first time because she had just been taken down. This is actually the, I should caveat this is the least offensive thing I found of her saying. So Tay was a chatbot that Microsoft developed that was supposed to learn from interactions. So it would ask you things, you would ask it things, and if it didn't know the answer, it would basically ask other humans, and then, like we learned with the autocorrect, it would start to see what things followed other things. So if you asked me, do you like to ski? And I said yes. If Tay asked me, do I like to ski? And I said yes. Then if someone else asked Tay, do you like to ski? She might say yes. So you start to learn what follows what. Unfortunately, the internet got a hold of this and decided to teach her that some not very nice things followed everything. And that's what happened. Which comes to sort of the main problem with machine learning. And I've alluded to it several times. Machine learning is only as good as your data. We have a phrase for it, GIGO, garbage in, garbage out. You may have heard that back in your old computer science classes. You can only be as good as what you train. And so if you have biases in your data, they're going to come out in what the system does. And so if you, this is not necessarily what happened to Google, but if you train only on people with light skin, that's all you're able to recognize. The same thing like with user experience testing. If you only test with 35-year-old males in tech, you're not going to really know how 12-year-old girls feel about your product, or 80-year-old people retired in Afghanistan. Like this is, you gotta get good data. Second problem is feature selection aliasing, is that you can only learn on the features that you use. And so if, trivial example, if I'm trying to learn the difference between cats and dogs, but all I ever look at is Actually, the nose might work, but I only look at small features that don't actually distinguish between them, like size. Everything under this size is a cat, everything under this size is a dog. You're going to miss small dogs because the feature isn't distinguishing enough. So you got to watch out for these things. Which leads to a whole bunch of questions I have. These are questions I don't work on, but I wish someone would give me the answers to. So I think everyone should just assume that your AI and your machine learning is going to do the wrong thing eventually. Either it's going to learn something wrong, or it's going to just go down the wrong path because you forgot to do an if loop someplace. So you have to design that failure in. So what should Tay have done when she started learning all these bad things? I don't know, but that should have been considered, right? How does this thing fail? It turned out they just pulled the plug, and all she said was, "I'm going to sleep," and then just stopped responding to responses at all, I think. How do you design adaptive systems? So if you're going to do an experience around interacting with an AI or an ML, it's going to change over time. So for some things like categorization, okay, just new categories show up. All of a sudden, now your pictures can also be mountains and beaches, when before they could only be mountains. But if you're doing more nuanced changes, how do you lead people to understand how things are changing? Because once they get used to one interface, if it changes on them, that tends to be bad. And more importantly, how do you test these things? Tay could have really benefited from some testing. Like, really. Did no one think, let's put this on 4chan and see what happens? Because you should have, right? And so I don't know what fields you work in, but like we work with children. So it's like, all right, let's give this to a 3-year-old and see what happens. They're going to throw it against the wall. Does it break? No. There's a great one. I should have put it up here. I was just at a conference, and they talked about the importance of testing. Google has a great page of the strangest things they saw while testing their self-driving car. Because you can't program for everything that you might see. For instance, there was a woman in a wheelchair chasing a duck with a broom across the street.
What?
Actual thing. Someone get on the internet and find the image. And it's just like, how could you predict that? How do you test for these things? I have no idea. And that's actually the last question. I thought I had one more, but I don't. So that's that, and I would like answers to these questions, please. Or I'll take questions. Or I'll take questions, yeah.
Question? Dan, I was wondering if you could talk a little bit about, which was really interesting, you talked about what the, and I don't know if you don't want to talk too much about Sphero because this is other things, but what the Sphero does when it hits a wall.
Oh, yeah.
How it says out.
Oh, yeah, I mentioned that last time.
Something else, and the baby that you talked
I remember that baby.
created, and what to do if you shake it, and not to train people to do bad behaviors.
Yeah, so there's all sorts of fun ethical and philosophical questions that come up when you start talking about engagement with artificial things and contingent responses. So I think the story I told was about Hasbro's My Real Baby,
Yes.
which was, anyone remember this? You might all be too young. It's a baby. It was a robot. So, little backstory. My research is in human-robot interaction, particularly about how to adapt robots to humans and have humans adapt to robots, and so apply machine learning to that interface, which is really fun. But how people react to robots is fascinating, and there's all sorts of ethical concerns. So the baby was supposed to be like a real baby. So it cried, you had to pet it, you had to burp it, you had to feed it. And one of the questions they had was, what should happen when you shake the baby? So who knows what happens when you shake a real baby? Yeah, who's heard the phrase, never, never, never shake a baby? Yeah, because you're never, never, never supposed to shake a baby.
Right.
So they scream, and bad things happen. And so the question was, should this toy do that? And one side says realism, like, yeah, you want people to, this should be a real experience. And the other hand is, no, because people know that it's not a real baby. And they know that if they do this, they're going to get a response. And people like responses. It's like playing slot machines. You like the lighting flash, you like the sounds. And so you might shake it just to get the response, since you're not actually going to kill it. But then you're going to put it down and pick up a real baby. And you're used to this baby-shaped thing. And what do you do when you have a baby-shaped thing? Well, you shake it to get that sound. and then bad things happen. So there's a really fun ethical quandary about transference of how people react to robots, or I'm going to broaden that and say any sort of artificial entity. This could be purely software. And does that transfer to how they play with other people? This is very reminiscent of the violence in video games debate, which, yeah.
My question, real quick, is that true then? Is that transference really happening?
No one knows.
Okay.
The research is on both sides. People have pointed to video games, be like, yeah, we have the most violent video games ever. Grand Theft Auto, what are we up to, like 5, 7, 8? I don't know. Some large number, greater than 1, has been out for a while, and it doesn't really seem to correlate to increased violence. On the other hand, you have other effects where, yeah, you see it. So you see things in autism therapy where people will play with robots or do things in the classroom, and then they're always looking for transference outside the classroom. And you see it sometimes, not all the time. And so no one's really sure when transference occurs and when it doesn't. And we don't know how to design for that. So if you're building a system that could have these effects, what are the responsibilities of you as the developer on the greater society? That's the thing I play with, or I struggle with all the time is, so the one you mentioned is Sphero. Sphero rolls around, and if Sphero smashes into the wall, it says, ow. Is this a good thing or a bad thing?
Good thing.
On the one hand, yeah, people, it's great, it's fun, the robot says ow, it's kind of cool. On the other hand, things saying ow, should that be cool? Because now...
It doesn't really hurt the robot.
Right, but now I know if I walk over and punch this guy, he's going to say ow, and ow is fun. I don't know. It hasn't actually, I mean, it's a robot ball, for goodness sake. It's like no one really expects that to transfer to me hitting people. But it's the start of a, oh, now we make it more lifelike. We make it more interesting and more animate. And then eventually you have robots. Anyone here watch Westworld? Yeah, I'm told I have to watch it. Yes. But apparently this is a common theme. They have artificially intelligent robots that people can do whatever they want to, which goes probably exactly where you expect it to go to, knowing people and having learned from Tay. So, yeah, is that a good thing or a bad thing?
Imagine these ethical quandaries are heightened with children, especially.
Oh, absolutely.
Vulnerable groups.
Yeah, when you're everything is turned up to 11 with children because they are so malleable and formable. So adults, we sort of expect you to have your own agency and like, come on, you should know better by now because you're in your 30s. Kids don't know. Kids learn, and they learn from everything. And so if you say it's totally fine to punch this thing that looks like a cat because it's a toy cat, if they can't distinguish, and if you get more and more lifelike, they might have trouble distinguishing between robot cats and real cats, and they punch a real cat, and you don't really want them doing that. So a lot of these things I think about a lot.
What did they end up doing with the baby?
They ended up not having it make a sound. So if you shake the baby, nothing happens. And that's because it's uninteresting. So the kids will shake the baby and be like, this is boring, and just never do it again. Even though it's not real.
Seems like a good way to go, considering all the other questions.
Yeah, but it's the trade-off between realism and these ethical considerations. Right. And that's a really, as you have systems that adapt and learn from their interactions, you get more and more of that. The big thing in self-driving cars these days is the trolley problem. Everyone familiar with this? You're in a self-driving car, reading your book, hanging out, driving towards a school bus full of children that's parked perpendicular to the road. Your car has a decision. Hit the school bus and kill the kids, or jump off the cliff and kill you. Which does it do?
What is your right answer? What?
I mean, it's probably going to save the driver over anybody else.
Well, that's a great question. So, classic utilitarianism says kill the driver and save the kids because there's more of them. But then who's going to buy a car that's going to kill them? Right? So all these systems start to come into play as you make things more autonomous, make them more intelligent. I see a lot of, and then of course, how do you test that? I have no idea. But a lot of these concerns start to come to the fore as we hand more and more of our lives over to internet and AI stuff. So a fun one today is recommenders. So who's read a book in the last year? Who's gotten that book off a recommendation from Amazon or Audible or someone like that? No? Okay, a few people. Who's read news online? Yeah. So you all know about the news bubble thing that happens, where you read a news story and then they recommend other news stories that tend to agree with that, and you start going down this rabbit hole, but everything sort of reinforces its own idea, and you never look over there, and you never see the other stuff. And then, the election happens. You're like, what? Yeah, that's because systems are recommending things to you that they know you like. Because if you like it, you'll give money, you'll click on the ads. And so you sort of get this really effective echo chamber coming up. And the question is, yeah, that makes money. And so you can use AI and ML to do that. But should you? And so I really believe that everyone who goes into these fields, everyone who's developing any of these technologies that actually have the potential to shape how people interact and perceive the world, should really think about the ethical implications of what you're doing.
Well, and perhaps other questions arise, such as the dilemma of should an AI be recommending what might be best for me, or what I might be most likely to consume?
Yes.
So if I have an addiction and the AI says, I know what you need,
Yep.
It could fuel certain behavior, or incentivize or encourage certain behavior that might be negative for me in the long term.
Yeah. People are looking into trying to fix that, or there is research into how do you get people to do things that are actually better for them and not just what they want to do.
Right.
It's hard. And yeah, there's no money in it, because if I'm a food recommender and you say I'm hungry and I know you like ice cream, I'm just gonna be like, hey, have some ice cream. And you're gonna like me because I keep telling you to have ice cream.
Yeah.
But in the long run, that's not good for you.
And if you're sponsored by Ben & Jerry's,
Yeah.
right?
Yeah, if I'm the Ben & Jerry's food app, I'm probably going to recommend ice cream all the time. But then you can see some pushback. So anyone buy a Pepsi or Coke product, I forget who does it, but they have the whole thing now, the stickers, balance what you eat, drink, and do. And that was because regulations came down that they're like, you're encouraging kids to drink too much sugary soda, you got to take steps. And so they've been great as a company, and they've stepped up and they've started to educate people about, if you've been out playing sports, reward yourself with a Coke or Pepsi, I forget who it is. And so they're trying to pair those things so you make better choices, but it's tough. Yeah, addiction bots are an interesting way to go. Anything else? Or I'm happy to talk about this stuff all night, but you can hit me up.
Questions that you got, anybody?
Nah, there's a guy with a camera. He doesn't have any questions.
That was fantastic. Thank you so
Cool.
much. We'll give it up to Dan.